I'm going to handle instrumentation and sensor technologies for civil engineering applications. Let us see transducers, sensors and transducers. Sensors and transducers. Before going to that sensors and transducers, we must understand what is electric current. Electric current. Electric current is flow of electrons in a conductor. Flow of electrons in a conductor. So here, what is conductor? Conductor. Conductor is a material. Conductor is a material made up of atoms, but it has free electrons. Free electrons. Free electrons means we know that all materials are made up of atom. There's nucleus. Electrons are in the particular orbit, fixed orbit. Suppose the electrons in the outermost orbit will escape if it gets energy from this fixed path. Those electrons are called free electrons. Free electrons. These free electrons will flow if flow in a conductor. If free electrons are there, then it is called a conductor. In a material, if free electrons are there, then it is called a conductor. In that conductor, the free electrons will be forced to flow through this conductor when there will be a pressure difference across, potential difference across the conductor. The potential difference is in volts. The flow of electrons, the quantity of flow of electrons is called current I, ampere. It is measured in ampere. This is potential difference is measured in volt. The analogy for volt, the analogy in civil engineering, the analogy for voltage is pressure difference. Pressure difference in a water pipeline. Volt is analogy to, identical to pressure difference in water pipeline. Current, this is pressure, potential difference or EMF. EMF. This is measured in volts, that is pressure difference in water line. Then current, what is current? Current is identical to flow rate. Flow rate of water in pipeline. That is measured in so many liters per hour. So many liters or gallons per hour. This is analogy to flow rate of waters in pipeline. Here current is in electrical, current is flow of electrons, quantity of electrons. Quantity of electrons in a conductor. So this is identical to pressure difference. This is identical to flow rate of water in a pipeline. So how to understand this flow of electrons in a water line? For that, let us consider this example. We have overhead tank in our home. We have a tap at the ground floor. If you open this tap, you will get the water flow rate. Say 5 liters per hour you are getting. This flow rate is function of pressure difference across these two ends. Pressure difference. Pressure difference across these two ends. Pressure difference across these two ends. Here atmospheric pressure. Here atmospheric pressure. This pressure is depends upon this height. This height The difference is between atmospheric pressure and pressure because of this height and this water column height. Say small h, let us call this as capital H, H plus H. Because of that, the two ends of the pipeline has some pressure difference. So because of pressure difference, there is a water flow rate. Flow rate. This flow rate, water flow rate is identical to electron flow rate. Electron flow rate in electric circuit. In electric circuit. This pressure difference is identical to pressure difference is identical to potential difference. Potential difference in electric circuit. This is measured in volts. This is measured in amperes. This is measured in volts. This is measured in ampere. This example, another example for electric circuit is here. Let us consider one electric circuit. This is the electric circuit. The potential difference developed by this battery is 5 volt across the two ends of the resistance AB. The resistance is 5 ohm. If you want to find an analogy between this electric circuit and water flow circuit in civil engineering, you will have a pump, centrifugal pump with a fan. This will develop a pressure difference across A and B because this is pump. This pump develop a negative pressure here, negative pressure here, here positive pressure. That's why the pressure difference is developed across the pump. If you take the circuit like this, here one tap is there, and this is connected like this. So let us assume that initially the tube is filled with water. Initially, this is filled with liquid water. If you turn on the pump, what will happen? It will develop a negative pressure here. That's why there will be a flow rate because of this pressure difference between A and B. There will be a flow rate of water. Say 1 liter per hour. 1 liter per hour. Here the pressure difference is developed across A and B by this pump. If you close this valve, tap, if you close this valve, there will be a less flow rate. This is identical to resistance in electrical circuit. Resistance in electrical. These two are identical. This is identical to battery. This pump is identical to battery. This 5 ohm resistance is identical to this tap. If you adjust the opening of this tap, the flow rate will be varied. Similarly, if you put more resistance, less current. If you put less resistance, more current. That's all. The current will be flowing through this way. Current is flowing through I ampere equal to 5 volt divided by 5 ohm. That's why 1 ampere current will flow through this part. This is the analogy for electric current. This current is called a DC current. DC voltage and DC current. Because if you plot between time versus voltage, always it is 5 volt. Always it is 5 volt. This is y-axis is in volts, x-axis is time. What is the voltage across this resistance is always 5 volt. This is DC volts. If you draw the current for the same circuit, always 1 ampere. 1 ampere. Ampere in y-axis, time axis in x-axis, always 1 ampere. This is also DC current. This is DC voltage. This is DC circuit. If it is a AC circuit, this is DC means constant voltage. Say 220 volt DC. AC means what will happen? This will vary like this. The power supply we are getting will vary like this. This is in volts. The voltage is varying from 0 to maximum, maximum to negative maximum, then positive maximum. Like that, it will vary 50 times in 1 second. 1 second. Then it is called 50 hertz power supply. Power supply. 50 hertz power supply. This is called AC supply. Suppose I'm having a water bath. In that water bath, I'm taking two water baths. I'm using an immersion heater. Immersion heater is used here. Here also immersion heater is used. The heater is used. Immersion heater is used here. Here I'm giving 220 volt DC. Here also I am giving 220 volt AC. Initial temperature of this water bath is 30 degrees centigrade. Here also 30 degrees centigrade. In 5 minutes, this becomes 100 degree centigrade. 100 degree centigrade. This is also becomes 100 degree centigrade. Then this is varying. It varies from this voltage varies from plus 376 volts to minus 376 volts. So how to call this? Maximum value is 376. That's why if these two produce this 276 maximum value produce same amount of heat, in both, whether it is AC or DC, produce same amount of heat. That's why this AC is equal to DC equivalent of 220 volt. That is called RMS value. RMS value is the DC equivalent value. So even though it is maximum value is higher, it is called 220 volt AC, 50 hertz AC. This is very much useful. AC is very much useful because it works, the transformer is works on AC, not DC. Suppose I want to transfer power from Neyveli to here. This is Neyveli to Pondicherry. I want to transfer power. In that case, the power produced here is 11 kilovolt. That is stepped up into Neyveli, stepped up into 25 kilovolt. Then it is transmitted to Pondicherry. This is Pondicherry. Here it is another transformer is used. 25 kilovolt is stepped down to 11 kilovolt. Again, it is stepped down to 220 volt AC. 220 volt AC. So here it is in Pondicherry substation. Here it is at our home. We are using a 220 volt. Why? Because the power produced here is 400 megawatts. That much power, if you want transfer at 220 volt, means you need a conductor size of building size. Conductor size will be building size. To reduce the conductor size, the voltage is increased because power is equal to VI cos phi. Cos phi is, let us assume, constant. Then if you increase voltage for a constant power, current will decrease. As current decreases, conductor size will be smaller. That's why it is transmitted at a high voltage. That is one of the advantage for using AC. Because transformer works in only AC. So we transmitted 25 kilovolt, reduced to 220 volt by using transformer. How the transformer works, that we will see now. Suppose I am having a coil. Coil means it is insulated wire. Some 500 turns are there. 500 turns are there. N equal to 500. 500 turns are there. Here I am giving 220 volt. Here I am having how many turns? 110 turns. I am having 110 turns. Here N equal to 110. Sorry, N equal to 250 turns I am having. Here N equal to 500. Here N equal to 250. So if you apply 220 volt here, here you will get 110 volt. How it is produced is, whenever you send the current through this coil will produce flux, magnetic flux. This will produce magnetic flux. Since it is AC, 50 hertz AC, it will produce varying flux, a varying flux. That is linked, that flux is going through this secondary coil. This is primary coil. This is secondary coil. Secondary coil. That's why these flux will link with the secondary coil. That's why let us assume that all flux produced by this coil is going through the secondary coil. It means 100% linkage. Linkage is 100%. Let us assume 100%. Therefore, if 220 volt here it is given, means 110 volt will be produced here. That is the transformer action. Now let us see what is if you, instead of using this air core, now the flux is going through air. If it goes through some air, less amount of flux only will link with the secondary coil. If you use iron core, because iron, if the flux goes through iron, it will be 800 times easier than air. That's why if you use iron core, most of the fluxes produced by primary will linked with the secondary. If you use the iron core, that's why iron cores are used. Here no physical connection between these two wires. Only through flux only it is linked to the secondary. This is called the secondary. The primary produces, in the primary we are connecting 220 volt to 50 hertz. Let us assume that we are giving 100 watts, means here secondary has two, here 500 turns, N equal to 500. Here N2 equal to, N1 equal to 500, N2 equal to 250 turns. Therefore, the voltage here will be 110 volts. But here also 100 watts. Watts will be same. So voltage is reduced. That's why current will be increased. That's why size of the conductor will be higher than this primary. This is called transformer principle. Transformer principle. When the voltage in the secondary will be induced, whenever this coil is placed in a varying flux. Here we are giving AC. That's why the flux here is varying like this. The flux is varying like this. Because the current is varying like that. That's why the flux in the secondary primary coil is varying like that. In the same flux linked with the secondary, here no voltage, no current, but the flux is varying. Here the flux going through this is varying. As flux varies, automatically and voltage is induced in the secondary. That's why there is a current. That's why if we connect a bulb here, that will glow. Without giving any physical connection between primary and secondary, the bulb will glow because the primary produces variable flux that's linked with the secondary. That's why secondary produces voltage and current. That's why the bulb will glow. This principle is called transformer principle. Its efficiency will be almost 100% because all fluxes linked with the secondary coil. If you remove the iron core, The flux linked with the secondary coil will reduce. That's why the power induced in the secondary coil will reduce. The same principle is used in LVDT. In the next class, we will see how LVDT works. We will see in the next class. LVDT means linear variable differential transducer or linear variable differential transformer. This is used to measure the displacement. Wherever the displacement is there, that can be measured by using LVDT. The next class, we will see how LVDT works.